Hello dear students, welcome to brilliantmaths.com, where every student has an opportunity to learn and excel in maths. Subscribe to brilliantmaths.com, take advantage of all the resources we have on the website, the books, the workbooks, the modules. Today's lesson is actually taken from Brilliant Maths Module 4. Let's go for a class. Today's lesson we'll be looking at area and perimeter of 2D shapes, precisely rectangles and squares, and then compound shapes made of rectangles and squares. The area of a rectangle is the length times the breadth. We all know what a rectangle looks like. That's a sketch of a rectangle. So that's the length. The longer side is the length, and the shorter side is the breadth. So length times breadth will give you the area of a rectangle. A square is a kind of rectangle, but in a square, all the sides are equal. So it's the same length times length for a square, since the sides are equal. The area is length times length. The perimeter of a shape is the sum of all the sides, the distance around the shape. Let's say for this rectangle, the perimeter will be the breadth plus the length plus the breadth plus the length again. The distance around the shape is the perimeter. So the formula is 2 into L plus B, where L and B are length and breadth. So length plus breadth times 2, because there are 2 lengths and 2 breadth. Then for a square, the perimeter of a square is 4L, because the 4 sides are equal. So you simply multiply the length by 4. Let's look at this example. It says, find the perimeter and area of the shape below. The shape below is a compound shape, but it can be split into 2 rectangles. Let's see how we do that. We have 3 centimeters, 2, and so on. I'd like to split into 2 rectangles in this form and call this rectangle A and call this rectangle B. The 2 shapes are the same. I drew them so that we could also split this way. And this is our A, and that is rectangle B. Whichever way you split them, your area and your perimeter would remain the same if you calculate it correctly. So looking at the first one, here we have a rectangle A and a rectangle B. The first thing you do is to find the length of the missing sides. We don't know what this length is, but we know that the base is 8 centimeters and the top is 3. So you look at the horizontal lines. If you are looking for the length of a horizontal line, compare with the other horizontal lines in the shape. So that's 3 centimeters and that's 8 centimeters. So the distance from here to here will be 8 minus 3, which will be 5 centimeters. I'll write it in a different color because we just found it. So that's 5 centimeters. We have this vertical line, and we don't know the length. But we know the length of this vertical line and this vertical line. So to find the length of any vertical line, compare with the other vertical lines in the shape. So this is 2, and that is 3. So the length of this side is 2 plus 3. So again, that is 5 centimeters. So now we can find the area, and we can also find the perimeter. So starting with the perimeter, take one of the sides and go clockwise or anti-clockwise. Keep to a particular direction so that you don't duplicate any side. Don't do it haphazardly. So I'll choose the top, and then I'll go clockwise. So 3 centimeters plus 2 centimeters plus 5 plus 3 plus 8 plus 5. And that will give us the perimeter of the shape. So let's do that together. 3 plus 2 is 5. 5 plus 5 is 10. 10 plus 3 is 13. 13 plus 8 is 21. And 21 plus 5 is 26 centimeters. So the perimeter is 3 plus 2 plus 5 plus 3 plus 8 plus 5 centimeters. And we said that that is equal to 26 centimeters. It's the same for the other shape because the shape is actually the same. So to find the area of A, find the dimensions of rectangle A. Rectangle A is a rectangle that measures 3 centimeters by 5 centimeters. So the area there is area of A equals 3 centimeters times 5 centimeters, which is equal to 15 centimeters. Then the area of B is the same here, 5 centimeters, which is this length, times 3 centimeters, which is also 15 centimeters. So we can then say that the area of the shape is 15 centimeters plus 15 centimeters. So B is equal to 3 centimeters times 5 centimeters, which is 15. So the total area will be 30 centimeters squared. All right? Let's look at it in the other one. The rectangle A measures 3 centimeters by 2 centimeters. 3 times 2 is 6 centimeters squared. Rectangle B measures 8 centimeters by 3 centimeters, as we can see. And 8 times 3 is 24 centimeters squared. 6 centimeters squared plus 24 centimeters squared would give us 30 centimeters squared, like we got the first time. So whichever way you partition your shape, if you've done it correctly, you should get the same answer. Let's look at another example. Here we want to look at example 2 and 3. Example 2 is a composite shape or a compound shape that can be split into rectangles or squares, as the case may be. And how many of it can we get? We'll find out. And example 3 is to find the area of the shaded portion in this shape. Very interesting shape. So looking at example 2, calculate the area and the perimeter of the composite shape below. We have the shape, which is a compound shape, and we want to split it up into rectangles or squares. There are 2 ways. You can split horizontally, and that would give you 3 rectangles. So I'll call this A, B, and C. That's one way. Let's use this method to find the area. What are the dimensions of rectangle A? A is 15 by 8 minus 3. Because the entire length is 8, but if it stops here, from here to here is 3 centimeters. So 8 minus 3 is 5 centimeters. So the area of A is 15 centimeters times 5 centimeters. 5 times 5 is 25. We carry 2. 5 times 1 is 5 plus 2, 75 centimeters squared. So that's A. Area of B. B is 3 centimeters by what? These marks signify that they are equal. The total length is 15. This portion is 7. So 15 take away 7 is 8. And 8 divided by 2 is 4. So that this length is 4 and that is 4. So B is 4 centimeters by 3 centimeters. So area of B is 4 centimeters times 3 centimeters. That gives us 12 centimeters squared. Area of C. C and B are similar. They are the same. So the area is the same. 4 centimeters times 3 centimeters. And that's also 12 centimeters squared. So the total area of the shape is 75 plus 12 plus 12. And that would give us 4 plus 5 is 9. 7 plus 1 is 8. And 9. So the total area of the shape is 99 centimeters squared. Try it out on your own by splitting the shape vertically to get your A, B, and C. And you'll find out that the answer will be the same. So for the perimeter of the shape, that is 5. We found all the missing sides already, so we just add. I'll start with 8 and go clockwise. So we have 8 centimeters plus 15. That gives us 23 centimeters. Plus another 8 centimeters. So 23 plus 8 would give 31 centimeters. 31 centimeters plus. So 31 centimeters plus 4 centimeters. That's 35 plus 3. 35 plus 3 is 38. Plus 10. That's 48. And 48 plus 4, and that is 52 centimeters. So the perimeter is 52 centimeters. Just take your time and choose a particular direction. Go clockwise or anti-clockwise. And make sure you don't add any side twice or leave out any for that matter. In example 3, we have a rectangle, an outer rectangle, and an inner rectangle, and the inner part is shaded. So what to do is find the area of the outer rectangle, and then find the area of the inner rectangle, and then find the difference. The difference will be the area of the shaded portion. So area of outer rectangle is 12 times 5. That is 60 centimeters squared. Then the area of the inner rectangle is 6 times 3. And that is 18 centimeters squared. The area of the shaded portion would be the difference. 60 minus 18. 10 take away 8 is 2. We have 5 left there. 5 take away 1 is 4. So the area of the shaded portion is 42 centimeters squared. You can get more practice from Brilliant Maths Module 4. In this part of the lesson, we want to learn how to find area of triangles. In the first triangle, in example 1, we have all 3 dimensions, 6 centimeters, 5 centimeters, and the base is 7 centimeters. And we have a height. It will be good to note that the height of the triangle is related to the base, because the height would make 90 degrees or is perpendicular to the base. So the base here is 7 centimeters. The area of the triangle is half base times height, or base times height divided by 2. But which base and which height are we talking about? For this triangle, the base is 7 centimeters and the height is 4 centimeters. So the area is 7 times 4 divided by 2. 2 there, 1. 2 in 4 is 2. 2 times 7 is 14. So the area of this triangle is 14 centimeters squared. But it will be good to note that if you want to use the base of 5 centimeters, then you should be finding a height that is perpendicular to 5 centimeters. So the area of a triangle is actually half base times height. But you must be careful to use the perpendicular height related to that base. So please take note of that. Example 2. 7 centimeters is the length of AB. AC is also 7 centimeters. So that tells us that this is an isosceles triangle. And we have 5 centimeters as the length of BC. But we don't know any height. It's not a right angle triangle. No height is given. In this case, we have to use half AB sine C as a formula for finding the area, where A and B are sides that include the angle C. So this is our A. If we have angle A on this side, side A is the side directly opposite the angle. So the angle has an uppercase letter and the length is a lowercase letter. So that's our corresponding A, side A. That's our corresponding side C. And this is our corresponding side B. So it's half AB sine C, the included angle, the angle between the given sides. If we want to use 7 and 7, then it will be half 7 times 7, the sine of angle A. But we don't know the sine of angle A, though it can be calculated. Since we know that it's an isosceles triangle, it also means that that angle is 65. 65 plus 65 is 130. 180 minus 130 is 50 degrees. So we can use half AB sine 50 degrees using that sign. But I've chosen to use 7 centimeters, 5 centimeters, and 65 degrees. So half AB sine C, half times 5 centimeters, times 7 centimeters, times sine 65 degrees. Carry out that calculation in your calculator, and you will get 15.86 centimeters squared, which is approximately 15.9 centimeters squared. You could try it out using half AB, the sine of angle A, and you'll see that you'll get the same answer. For more examples, get a copy of Brilliant Maths Module 4. Here we want to learn how to calculate the perimeter and area of parallelograms and trapeziums. All right? Example 1 is find the area and perimeter of a parallelogram whose base is 5 centimeters and the height is 7 centimeters. So the parallelogram is here. The base is 5 centimeters. The height is 7 centimeters. The sides are 9.6 centimeters. That was not given, but it's in the diagram. The area of the parallelogram is base times height. So that's the base, 5 centimeters, times height, which is 7 centimeters, and it's 35 centimeters squared. That's the area. Then the perimeter, like we all know, is the distance around the shape, the sum of all the sides. So 5 plus 5 plus 9.6 plus 9.6. That's 5 plus 9.6 times 2. And that will give us 29.2 centimeters. So that's the perimeter of the parallelogram. But remember that the area of a parallelogram is base times height, perpendicular height. In example 2, we have a trapezium. A trapezium is like a triangle and a rectangle joined together, like a compound shape made of a triangle and a rectangle. This is a type of trapezium. The parallel sides are 6.5 centimeters and 8 centimeters long. The area of a trapezium is half into A plus BH, where A and B are the parallel sides. So half times the sum of the parallel sides times the height of the parallelogram. So half into, the parallel sides are 8 centimeters and 6.5 centimeters. So you add them together and then multiply by 5 centimeters, which is the height. And you'll get 36.25 centimeters. I'd want you to try out the area of this shape by finding the area of the triangle and finding the area of the rectangle and then adding both of them together. You'll discover that the answer is the same. Do try it out. In this example, we want to learn how to calculate the area of kites and rhombuses. All right? We have a kite in example 1. The question says the diagonals of a kite are 14 centimeters and 22 centimeters long. Find the area of the kite. The area of a kite is half the product of the diagonals. So once you know the length of the diagonals, you multiply them and divide by 2, and you get the area of the kite. You can find the proof of that formula in Brilliant Maths Module 4. So go get a copy. In this diagram, the diagonals are 12 centimeters and 22 centimeters respectively. So the area of this kite is half times 14 centimeters times 22 centimeters. Half of 14 is 7. And 22 times 7, 7 times 2 is 14, carry 1. 7 times 2 again is 14 plus 1, 15. So half the product of the diagonals will give us 154 centimeter squared. So that's the area of this kite. In example 2, the sides of a rhombus are each 5 centimeters long, and the length of one of the diagonals is 8 centimeters. Find the length of the other diagonal. All right? We've sketched the rhombus. The sides are 5 centimeters. Remember that the rhombus is a square pushed over. We have one diagonal, which is 8 centimeters, and we're supposed to find the length of the other diagonal. So we mark there as T, as midpoint, half of the diagonal we are given, so that if the entire length is 8 centimeters, half the length will be 4 centimeters. So to find the length of the other diagonal, we can use Pythagoras theorem. So AB squared minus AT squared is equal to BT squared. Our AB squared is 5. The AT squared is 4. So BT will be equal to the square root of 5 squared minus 4 squared. 5 squared is 25. 4 squared is 16. So 25 minus 16 is 9. So BT is the square root of 9. And BT is half of the length of the other diagonal. So then, to find BD or DB, which is the second diagonal, BD is equal to 2BT. So the length of BT is 3 centimeters. So BD will be 3 centimeters times 2, which is equal to 6 centimeters. So the second diagonal is 6 centimeters. For more examples on the areas and perimeters of rhombus and kites and 2D shapes in general, get a copy of Brilliant Maths Module 4. Hello students, I hope you enjoyed that lesson on areas and perimeters of 2D shapes. Go get a copy of Module 4, Brilliant Maths Module 4 if you don't have one already. Subscribe to the site and always remember that maths is fun and you can do it. My name is Ngozi Orevod. See you during our next lesson.